Calculations of magnetic field using Ampere circuital law. Solid infinite wire. Inside capital R greater than small r. Outside small r greater than capital R. B is equal to mu naught J r upon 2. B is equal to mu naught I upon 2 pi r. Ideal solenoid. B is equal to mu naught Ni. Toroid. Ideal solenoid is bent to form circular ring, then it becomes toroid. N is equal to capital N upon 2 pi r. Number of turns per unit length. B is equal to mu naught Ni upon 2 pi r is equal to mu naught Ni. Infinite current carrying sheet. B is equal to mu naught lambda upon 2. Magnetic force on moving charge in magnetic field. F is equal to Q VB sin theta. Magnitude of force. Put only magnitude. Theta is equal to angle between V vector and B vector. F is equal to Q in bracket V vector into V vector into B vector. Magnetic force acting on moving charge. Put with sign. Velocity of the charged particles. Magnitude field. Magnetic field on the axis of a circular current carrying loop. B is equal to mu naught Ni r square upon 2 in bracket r square plus a small r square to power 3 upon 2. Magnetic force on moving charge in magnetic field. Fm is equal to Q in bracket B vector into B vector. Magnetic force acting on moving charge. Put with the sign. Velocity of charged particles. Magnetic field. F vector is equal to QV B sin theta. Theta angle between V vector and B vector. Magnitude of force. Put only magnitude. Motions of charged particle in uniform magnetic field. Radius of circular. Frequency. F centripetal is equal to mv square upon r. R is equal to mv upon qv. Frequency F is equal to 1 upon T is equal to qb upon 2 pi m. Time period of revolutions of charges particle. T is equal to 2 pi m upon qb. Angular velocity omega is equal to 2 pi upon T. Omega is equal to qb upon m. A charge q accelerated through v volt. It means that a qv kinetic energy radius of circular where charge will move. R is equal to mv upon qb is equal to p upon qb is equal to under root 2m ke upon qb is equal to under root 2m qb upon qb. Qb is potential difference through which q is accelerated. Magnetic field due to moving charge. D B vector is equal to mu naught I upon 4 pi in bracket dl vector into r vector upon r vector power cube. B is equal to mu naught q upon 4 pi in bracket b vector into r vector upon r vector power cube. Note: rest charge produced only electric field, but moving charge produce both electric field and magnetic field. Lorentz force. F vector is equal to Fe vector plus Fm vector. Lorentz force QE vector plus Q in bracket B vector into B vector V vector into B vector. When Lorentz force be 0, E is equal to negative in bracket B vector into B vector. Electric force and magnetic force are equal in magnitude and opposite in directions. Velocity selector V is equal to E upon B. Selected velocity